Hi, I am Lopamudrashin. Welcome back to my channel Electronic Science Tutorial. I will start a new lecture series on VLSI technology. Today is the 16th class of this lecture series. Those who are not follow my channel, please follow my channel. If you like my channel, then please like, share and subscribe my channel. सब्सक्राइब की बेल आइकन को प्रेस करके रखिए ताकि जब भी मैं कोई नई वीडियो लेकर आऊँ आपको पता चले. So let's get started. Welcome to VLSI technology series. In previous class of this lecture series, we talk about the various properties of the crystal plane and also we discuss about the important observation of geometric consideration like how we calculate the angle between the two planes. Second point, what is the line equation of crystal plane, and also we discuss how we calculate the separation between the two adjacent parallel planes, and from there we get least spacing crystal plane. In today's class we talk about one more important observation, that is how etching is done in least spacing direction in crystal structure. Let's start the discussion. Okay. In this slide, we talk about the least spacing crystal plane and why this least spacing crystal plane is important in VLSI technology. We discuss here. We discuss why silicon etching is difficult in 111 direction. Because of this least spacing reason, it is more difficult to etch silicon in 111 direction. Least spacing means they want to stay together. That means it is difficult to etch them off. Okay. There are many chemical agents. When silicon is subjected to those chemical agents, it etches selectively. That is, it will etch other planes, but it will not etch 111 plane. Therefore, when you are etching 111 planes, it will be exposed, right? The etching will stop when it encounters an exposed 111 planes. Okay, this is very important observation of 111 crystal plane, right? In this slide, we talk about V-groove etching. Let us consider this diagram. Okay, this is an 100 wafer. This is an 100 wafer. You have exposed this wafer to a selective etchant, which is going to expose the 111 plane. Okay. Now we calculate the angle between the 100 plane on the surface and 111 plane which are going to expose, right? We already know about this relation, that is when we calculate the angle between two planes like x1 y1 z1 and x2 y2 z2. What is the equation? That is cos theta equal to x1 dot x2 plus y1 dot y2 plus z1 dot z2 divided by root over x1 square plus y1 square plus z1 square dot x2 square plus y2 square plus z2 square. Okay. So here we consider two plane, that is one is 100 plane and the other is 111 plane. So what is the next step of this calculation? That is cos theta equal to, we consider here x1 y1 z1 is 100 plane and x2 y2 z2 is 111 plane. So by putting the value, what we get here, that is 1.1 plus 0.1 plus 0.1 divided by root over 1 square plus 0 square plus 0 square dot 1 square plus 1 square plus 1 square. What we get from this equation? That is cos theta equal to 1 by root over 3. That means theta equal to 54.74 degree. Why this angle is important? Let us discuss here. Okay. So, here we consider the cross-sectional diagram of 100 wafer. Okay. Now, we exposed it to the etching through this window. Through this window, we etch this 100 wafer. Okay. So, what happened? The etching is going to proceed like this. Etching is going to proceed like this. And the angle is to be 54.74 degree, right? So, this 111 plane meet to the 100 plane at the surface of 54.74 degree. What does it mean? It means that this is 100 plane and this is 111 plane. So, when we etch this in this way or in this way, the angle is 54.74 degree. So, this is an very important properties of the 100 and the 111 planes. If I continue etching, what I realize that finally the etching process cannot proceed any further. Okay. So, it is going to stop here in this point. Right. So, it is going to stop here. This height is called, that means this height. This height is called the width of the etching window, right? That means I can control the etching by this window. It will be a self-limiting etching. Okay. So, finally etching will stop at this point, no matter how long we continue the etching process, right? This is a very important observation of 111 plane. This process is called V-groove etching. Okay. This V-groove etching has various interesting application in VLSI technology. We talk those topic in another slide. Okay. So, here we end today's session. Thank you. If you like my video, then please like, share and subscribe my channel. फिर मिलते हैं एक नई वीडियो के साथ. Thank you.